So we start with Tom Macwright from Placemark, and he's going to tell us about how real-time geospatial data can work.
Excellent. All right, I'll keep this to 5 exactly. All right, hello, thank you for having me. I'm Tom, I'm working on Placemark. And so, yeah, this talk is about real-time collaboration, which is very common across a lot of other software categories. I'm sure that you've used it if you've already used Google Docs and seen other people editing. And this talk is basically about in application to Placemark.io. So it's kind of the successor to geojason.io and a new map editor that is focused on collaboration. So if this was just slapping real-time technology on geospatial, I would have finished the project 6 months ago and wouldn't have much to talk about. So this talk is kind of from the perspective of the geospatial world and like, you know, what are the problems here? All right, so the first problem is going to be addressability, which is a different concept of addressability than what the geospatial world probably would think that is. It's essentially how do you communicate small changes about data? Because collaboration is all kind of about just like people on the same document communicating changes back and forth. So in this case, addressability would be like the index of a character in the string, and it has a position. The state of the art for this in geospatial is muddled and kind of bad. We usually have arbitrary IDs that are numeric that always overlap between different data sets. I think one really interesting example of a project that focuses on addressability is OpenStreetMap, in which not only do things like a building polygon have identity, the individual vertexes of that building polygon have their own IDs, so you can just move one vertex. So what Placemark is doing is using UUIDs, which are longer IDs with 128 bits of entropy instead of what a number would be, which is usually around 52 in JavaScript, and then using JSON path to refer to coordinates. So in this example, you would have a point, and the point's ID would be this long string of random characters, and then we would have a way of representing to one coordinate in that point. So if you're dragging just that coordinate, we can communicate that coordinate being dragged. So the second topic, conflicts. So what if two people edit the same data set at the same time? So a lot of the geospatial world is still at the point of naming files and hoping that nobody else edits the same file at the same time that you're working on it. OpenStreetMap moves past this a little bit in sort of a way that you can check data out, edit it, push it back, and then hope that nobody's edited in the meantime. But the real-time norm is that nobody ever sees a conflict. So the technology that I recommend just diving into is called CRDTs, which are conflict-free replicated data set types. And so what this basically does is that if there is a conflict, you create a set of rules in which it defines which edit wins, or if multiple edits happen at the same time, how those edits combine. So if somebody changes a property of a geometry at the same time as somebody else is changing the geometry, a coordinate of the geometry, it's able to merge those two things. All right, so the topic 3, which kind of pulls out of the CRDT thing, is speed. Geospatial is one of the most challenging problem areas, I think, for speed, because we work with gigantic data sets. We want to see all of it at the same time. It could be a lot of stuff. I think the most crazy part about it is stuff like the coastline paradox, in which a sufficiently detailed coastline can be so large that even just somebody moving one point of the coastline is something that's actually really hard to communicate. In real life, you can see this in the OpenStreetMap project. And unfortunately, CRDTs at their current state are still slow. They're working out of a state of being slow. Thankfully, they're getting a lot faster. So during the time that I've worked on Placemark, the tools that I've been building this on have gotten about 2x faster. But this is kind of part of the whole living on the bleeding edge here. So in situ, Placemark is the product that I'm building. And in this, you can drag one point in a large data set, and everyone can see that point moved and synced. And that's because every feature has IDs, because it's using a CRDT under the hood. And then, yeah, so I think the questions that come up are versioning, difficult, big data, difficult, decentralization is almost not possible at this point. But that's for a future talk. So thank you.